Uniform motion doesn't often exist in nature, but if we're driving on cruise control or if we're parked, we're experiencing uniform motion. Hi, this lesson is going to be on using graphs to analyze motion. So a position time graph is a graph that shows us the position of an object over time. And the slope of this position time graph allows us to find the rate of travel. If we have a distance time graph, that will be speed. And if we have a displacement time graph, that's going to be velocity. So we can calculate the slope of the line, and this allows us to find the rate of travel. We're going to find 2 points that are on the line, and ideally you want to find points that cross over axes direct, like very specifically, so that we're not dealing with decimals of numbers. So you want to find a point on the graph. Usually we'll choose that is the origin, and then another point on the graph that crosses an axis really nicely. To find the rise, we find the difference between point 2 and point 1 on the y-axis, and to find the run, we use the difference between point 2 and point 1 along the x-axis. And then the formula to calculate slope is rise over run, so the change in y over the change in x, which gives us y minus 2, y2 minus y1 over x2 minus x1. And coordinates are always given in the format of x comma y. So the coordinates for point 1 are 0 comma 0, and the coordinates for point 2 are 10 comma 100. So if this graph was a cyclist leaving home at point 1 and traveling at a constant speed, after 10 seconds, point 2, she has traveled 100 meters. What is the slope of her graph? What does this information tell you? So we're going to show here that she has traveled 100 minus 0, 10 minus 0. So we have a total speed of 10 meters per second. So this tells you her speed, because for velocity, we would need to have a direction, either positive or negative, or north, south, east, or west. So there's 3 possible trends for a position time graph. We can have a graph where time elapses, but the position does not change. And this is where there is no motion or the object is stopped. We can have a uniform motion position time graph where as the time increases, position increases at a constant rate. And then we can have a graph with accelerated motion where the position changes at a curve compared to the time. And so the slope of a distance time graph is speed. So this information can then be transferred to a speed time graph. Generally, we won't calculate the slope of accelerated motion graphs, but we will of uniform motion graphs. When we're plotting speed time graphs, the speed time graph has the manipulated variable time always on the x-axis. So time will always be on the x-axis of a speed time graph, and speed will always be on the y-axis of a speed time graph. Okay. So we can have a position graph or a speed time graph. You really have to check those axes. So if we're looking, the slopes of the 3 lines are 5, 3, and 1. So this graph has a slope of 5, this one has a slope of 3, this one has a slope of 1. So if each of these is traveling in uniform motion, our speed does not change over time. And this one would be the fastest with our slope of 5. Object, and then 1 would be the slowest. But if we graphed this same position in a speed time graph, we would have 3 flat lines. Now this is because speed is not changing over time. So the top graph is position, the bottom graph is speed. So if we're looking at a speed time graph, the slope of a horizontal line is always 0. And on a distance time graph, that means that there's 0 change in position. But on a speed time graph, that means there's 0 change in speed. We have uniform motion. We're not experiencing any acceleration or deceleration. So although the slope of a uniform motion speed graph can allow us to develop a trend, the area under the line can be used to calculate distance traveled. So even though the slope doesn't give us any information, we can calculate the area under the graph to calculate distance traveled. So the area of a speed time graph, we will calculate by length times width. So length is going to be the y-axis, is always going to be time, or sorry, the length or the height is going to be the speed on the y-axis, and then the width is going to be the x-axis, which is going to be time. So the formula can be written as speed multiplied by time, the x-axis multiplied by the y-axis, which is the same as the distance formula. And so if we measured this one, we had an average speed of 5, and the time elapsed was 30 seconds. So we could have traveled at 50 meters if our units, our speed is in meters per second and time is in seconds. So we calculate the area under that graph to calculate the distance traveled. Now you could also do this with a sloped graph, but you're going to have to use a different area formula. You would have to use the area of a triangle. So that's a little bit at looking on speed time graphs. I hope you enjoyed your lesson.
If you enjoyed this video, check out our website online.plrd.ab.ca and visit us on Facebook, Prairieland Online Academy. You can find out all that's going on with Prairieland Online Academy.